Welcome, students. Actually, today we will revise the whole chapter, that is light. Okay, and we all know that light is one type of energy. Okay, that causes sensation of vision in our eyes. Okay, with the help of light, actually we see any objects. Okay, and we actually discuss the properties of light. In generally, in your syllabus, there are actually total three types of property. Actually, three properties. First one is actually reflection of light, and second one is refraction of light, refraction of light, and third one is actually dispersion of light. That is a part of refraction. We can say refraction of light through a glass prism. Okay, or we can write as number 3, that is dispersion. Okay, now question is, what is reflection of light? Actually, we can say that when we take a polished surface, then actually light, when light is actually incident on a polished surface, then light gets reflected. Okay, so in general, suppose we take a surface like this is your suppose polished surface, and light is incident on the polished surface. Then actually after striking the surface, light actually gets reflected. Okay, so here we can say, this is, if we take as AO, this is your incident ray, and OB is the reflected ray, and the imaginary line which is perpendicular to surface, reflected surface, that is ON. Here ON is the normal. Okay, so actually reflection occurs for different types of mirrors, we can say. Suppose mirror are actually for reflection, we can take two different types of mirror. For this reflection, we can take one is plane mirror, and another one is actually spherical mirror. Okay, so we have to know about actually images formed by a reflection for different types of mirror like plane and spherical mirrors. Okay, and what is plane mirror? When actually reflected surfaces or polished surfaces is plane, then we can say this is your plane mirror. And what is spherical mirror? Spherical mirror means actually the reflected surfaces or polished surfaces is curved. Okay, and here also we have to know spherical mirror are two types. Okay, that is, one is actually concave mirror, and another one is actually convex mirror. Okay, and here actually concave mirror is known as converging mirror. This is known as concave, that is known as converging mirror, and convex, that is actually diverging mirror. Now the question is, why concave mirror is called converging and convex mirror is called diverging? Because for concave mirror, when suppose parallel light from infinite distance is incident on a concave mirror, which is parallel, that means which is parallel to principal axis, then actually it converges. Okay, after converging, actually they can meet a point, that is actually focus in generally. So for this case, actually parallel light converges. That is why concave mirror is called converging mirror. And what is convex mirror? Actually, for convex mirror, when parallel light uh, is incident on convex mirror, then they gets diverges, and they actually diverge from a point that is called focus point. Okay, so that is why actually convex mirror is called diverging mirror and concave mirror is called converging mirror. Okay, and also you have to know here actually what are the properties of images for different types of mirrors. Suppose we take plane mirror. Okay, so suppose we take plane mirror. So for this plane mirror, actually, what is the image size? We already discussed in your class that image formed by a plane mirror is generally this is actually a virtual image, erect and same size of the object, and also the distance between mirror and object is equal to mirror and the distance between mirror and images. Okay, that means we can say object distance is equal to image distance for plane mirror. And here actually the image is in the nature of image is virtual image. Okay, in generally image are two types. Okay, so image in generally two types. One is actually real image and another one is actually virtual image. Now the question is, what is the basic difference between real and virtual image? So simply we can say after reflection, when actually reflected rays meet to a point, okay, then we get an image real. Okay, or after reflection, when we see that reflected rays are appeared to meet, then we get virtual image. Okay, in generally for real image generally gets actually inverted, and for virtual image we gets actually erect images. Okay, and we can say that we can actually get real image on a screen, but virtual image can't get on a screen. Okay, so this is the basic or main difference between real and virtual image. For plane mirror, actually we can say that we get actually virtual images same size, that means erect, and also erect as it is virtual, and the same size, and also the distance, that is image distance is equal to object distance. Now if we take suppose different types of mirror, that is suppose we take here first one is concave mirror. Okay, so for concave mirror actually there are several properties. Okay, or we have to know some terms which is related to concave mirror. Suppose focal length, focus point, okay, principal axis, center of curvature, radius of curvature, and pole. Then these are the common terms, okay, which is related to convex and also concave mirror. Okay, and we already know what is the definition of these terms. Okay, so we don't here actually discuss about the definitions. Just to clarify, I can say that actually image characteristics of image depends on the position of the object. Okay, in generally when suppose object is placed sub for concave mirror, okay, uh, infinite distance, then actually we get a very diminished and real image at focus point. Okay, and if we suppose take an object at suppose beyond center of curvature, so we can say we get an image that is also real. Okay, similarly if suppose but the size of the image is actually small. Okay, and more smaller than actual object, and also when object is moved to center of curvature, then also we get real image. Then again object is placed between center of curvature and focus, then we also get real. For this focus point, obviously we get actually real image. But suppose actually we take an position, that is actually suppose object is placed suppose in between focus and actually pole, then actually we get a virtual image. Okay, so there are one condition in which actually for concave mirror we can get a virtual image, that is object is placed between pole and focus. For this particular case we actually get an image behind the mirror, that means we get actually erect and virtual image. Otherwise for concave mirror, for all the positions we get actually real and inverted image. Okay, but size is different, that is not actually in the process. Okay, that is depend on the position of the object. And for actually if we take suppose convex mirror, so for convex mirror, as this is actually diverging mirror, always actually for convex mirror we get virtual and diminished image that is formed behind the mirror. Okay, actually this is there is not necessarily the position of the object. If an object is placed in front of convex mirror, then we get virtual and diminished image. Okay, and here actually we have also know about what are the actually uses of spherical mirrors. Okay, we already know the uses of convex and concave mirror. Okay, that is not actually described here. Okay, I do not describe in this class. Just move to the next rule or next properties, that is refraction. Okay, and what is refraction? Generally, when light travels in one medium, then actually lights move in a straight path. That is the property that is called rectilinear propagation of light. Now, if suppose a light travels in a medium and suddenly the density of uh, medium is changed. Okay, or we can say suppose a light is traveled from one medium to another medium of different density, then actually what happened? Okay, then actually lights actually bends. Okay, in such a direction. Okay, in such a direction actually, or in any direction actually light bends. This property is actually called refraction of light. Okay, there are actually two rules. Okay, yeah, we take as rarer medium and denser medium. If suppose light travel from rarer to denser medium, simply light gets deviated or light bends towards the normal. Otherwise, if light moves from denser medium to rarer medium, then actually light bends away from normal. Okay, and for the past case, when rarer to denser medium, then their actually incident angle is greater than refracted angle, and we get deviation angle I minus r. And for the second case, if light bends away from normal for denser to rarer case, then we get r angle greater than I angle. And for this case, deviation angle, that means the angle in which the incident ray deviated, this angle is calculated by actually r minus I. Okay, so these are the rules of refraction of light. Okay, now the question is actually, if refraction occur in suppose prism. For prism actually we get actually again refraction, but when white light passes through a prism, then what happens? We know white light actually is the combination of seven colors. Okay, and we also know that for a seven color actually the speed of light is different in such a material, or for a particular material. Suppose light enters from air to denser, that means from air to glass medium, because film is made of glass, so white light travels from air to glass medium. Then in glass medium, the speed of different seven colors actually is different. So for this case actually, after refraction, white light split into seven different colors due to their velocity. Okay, so as the speed of red is very high, so at first actually um, red emerges through actually prism, and we get actually minimum deviation. Okay, but we get maximum deviation for actually violet, or we can say for violet actually the speed of light is very small. Okay, that is why we get more angle of, or more angle of deviation. Okay, in generally this is actually dispersion of light. Okay, this phenomena where light split into 7 different colors, and also we get 7 different colors, that is called spectra. Okay, and this is actually refraction. From refraction we get behavior, and this is your actually spectrum of light. Okay, and some natural phenomena that is occurred due to dispersion, such a example is a rainbow. Okay, for a rainbow case, we can say that actually uh, for after actually rain, some small air drops actually floats. Sorry, water drops it floats in the atmosphere, and when sunlight is travel through these teeny water droplets, and these tiny water droplets behave as a prism. So after refraction actually we get a spectrum in sky. Okay, that is called image dispersion. Okay, so actually this is the complete syllabus. Okay, or complete chapter. You have to know what is light, what are the properties of light, suppose reflection, refraction, and dispersion also, and also know different types of mirror, suppose plane mirror and convex concave mirror, how image formed for convex and concave mirrors, and also plane mirrors. And you have to know the different terms which is related to convex and concave mirrors, and also know about two types of image, that is real and virtual. What is the difference between, what are the differences between real and virtual images, and also know about what is refraction, how it occurs, and what are the rules of refraction of light. Okay, when light actually travels through a prism, then what happens, what do you mean by dispersion, spectrum, and also know about rainbow. Okay, so this is the end of today's class. Okay, and in the next class we discuss again, or we repeat again.